Okay, so at this point we have already learned many formulas that are being used in order to present certain regression results. And it's getting time now to verify those formulas in the context of the example that we started out with. So if you go back to our early slides, we had a regression, we had 6 observations, and we got a trend line where the intercept was 3 and the slope was 1. And we derived along the way many formulas, and let's actually work with them now and see what Excel got. So this is our data again, xi, yi, and then we drew it, and then we had all our formulas. So the first formula we got was for, let's start with the slope coefficient. So we want to estimate a regression line, which is yi hat equals a plus b xi. Okay, so how did we determine b? And we said b is the covariance between x and y, which is given by xi minus x bar times yi minus y bar over the sum of xi minus x bar squared. So that's the covariance over the variance. The intercept of the regression, A, we derived as y bar, the mean of all the y's, minus the slope coefficient b times the slope of times the mean of x bar. And then we had some variances. We had first the standard error of the regression, and the standard error of the regression yx we derived as the square root, and that's an arrow, as the sum of all the deviations of the y from the trend line, y hat squared, so that's similar to the variance, over the degrees of freedom, which in our case is now n minus 2, because we estimate 2 parameters, a and b, but we have a total of 6 observations. Then we looked at the standard error of a, and that was the standard error of the regression times the square root of the sum of all the xi squared over n times the sum of xi minus x bar squared. And lastly, what we calculated is the standard error of the slope, and that was a little bit easier. That was just the standard error of the regression over the square root of the sum of all the square deviations from the mean. This is what we got. So let's work with those results, and what I do is I copy them into Excel. So let me cut all that information here. And I'll just copy it quickly. And now let's open Excel. And I'll just paste it somewhere here. And maybe make it a little bit smaller. And then we can see it. Okay, so now let's actually see what we get in Excel if we apply everything. So we have our variable xi and yi. Okay, let me just copy this one. 0, 2, 2, 4, 4, 6. The dependent variables are, and those are the ones that matter somehow, 3, 6, 4, 9, 5, 9, 9, 5, 9. So if you look at those formulas to the right that we derive, we need a couple of things. So the one thing that we need is the mean. So let me insert here a column and let's calculate the mean for all the x's that we have in Excel, that is equal to average. And then we highlight all the x's. And the mean of x is 3. And if I copy that to the right, then I see that the mean of y is 6. So we need the means in order to calculate several things. Okay, so one of the things we need is all the deviations from x minus x bar. Okay, let's do that. Let's create a column which we call xi minus x bar. So xi minus x bar, so we subtract from each x the mean. So I then go with my cursor to the mean and I F4 that cell, and then I can copy it down. Okay. So, and you see when we always set the sum of the xi minus x bar, well, they are always 0. And we can see if we sum up all those values, you can see down here in Excel that the sum is 0. Minus 3, minus 4, minus 5, minus 4, minus 3, 0, if you sum it up. So now we need to do the same for yi minus y bar. So here I forgot the I. So yi minus y bar. Okay, so now we go with the cursor into cell C2 where I have the first value of my y's, and I subtract the mean which I have in cell C8, and don't forget to F4 it and put the $2 signs around. And then we copy down the formula, and you see again that the sum is again 0. So let me fit everything maybe to content. So maybe I can make it a little bit bigger. Okay, so what do we need next? So we have xi minus x bar, so we need the product. So that's the covariance. I just call it covariance of x and y. But please keep in mind that I do not divide by n minus 1, because we don't need that. We just need what we see here in B. So, but now I just multiply xi minus x bar times yi minus y bar. Okay. Okay. Well, and now we need to sum that up, because the sum, or the covariance, which is the sum of xi minus x bar times yi minus y bar, well, that will go into the numerator. So this sum is equal to okay, so that would be equal to 22. Then if we look at b, we also need xi minus x bar squared. Okay, so that would be xi minus x bar squared. And let me superscript those. We can go to home for and then superscript. Okay, we have xi minus x bar squared. So we just navigate now with our cursor into cell D3, square it, copy it down, and sum that up. And it's 22 equals the sum, and that's also 22. So now we can calculate the slope. So the slope is the covariance of x and y, the 22, divided by x, the sum of xi minus x bar, and we get indeed 1. Okay, so now we can also calculate the intercept. And we can see that the intercept is given by the mean of y. We have already calculated that is the 6, so click into the 6, minus the slope times the mean of x, which is 3, and indeed we get 3. Okay, so now let's move to the standard error of the regression. Standard error, and then I call it y/x. That's the standard error of the regression. Okay, so now we need to pull up those formulas, maybe make it a little bit smaller, maybe we still need something. Maybe put it here quickly. Okay, we still need the y hats. Okay, so y hat, so that is the predicted value. So now we know that the predicted value is equal to 3 plus 1, or the slope. I can actually navigate to the slope, F4 it, plus the slope and navigate. Oops, I should not have navigated to the, okay, let's do it again. So navigate to the intercept of 3, in my case cell B11, F4 it, plus the slope, which I have in cell B10, and then we press again F4, times the x value, and I click into cell B2 where I have my first x. So now the first predicted value for x equals 0, well, that's the intercept of 3, and let's copy down that formula for our 6 observations. So now we have all the y hats. What else do we need? Well, we need to derive the yi minus y hat squared. So we go to create a new column and call it yi minus y hat and square it. Then I superscript again the 2. Okay, so now we just navigate to the cell where we have our y's, and we subtract the predicted value, close the parentheses, square it by 2. And we copy it down. Okay, so now we can calculate again the sum. So the sum is equal to So now we can calculate the standard error of the regression. And now I maybe go here. So the standard error of the regression is simply equal to the square root of the sum of the yi minus y hats, which is the 10. So I click into the cell with the 10, and then divide by the degrees of freedom. And the degrees of freedom is because we have 6 observations. 6 minus 2, that's 4. And I close the parentheses. So now our standard error is 1.581, but that's just limited to 3 digits. That's good enough. Okay, let's move next to the standard error of the intercept. And for that we need the standard error of the regression, and we still need the squared x's. So we need one more column, which is xi squared. So let's superscript that again, xi squared. So that is equal to xi squared. Let's copy that down. Okay, so then we need to calculate the sum. So the sum of all the xi's squared is 76. Okay, and then we have to divide by n times the sum of the xi minus x squared, which we already have. The xi minus the x bar squared, we already have that. So the standard error of A is equal to standard of the error of the regression. Okay, so I click into the cell with the 1.581 times, okay, the square root all the xi squared, that is the 76. So I click into the cell with the 76. And now we need to divide by, in parentheses, n 6 times the sum of the xi minus x bar squared, which is the 22. So I click into the cell with the 22, which is in my case G9. Actually, we don't have to F4 it, and then we have to close the parentheses. And then we get 1.2. And let's round it again to maybe 3 digits. That's good enough. Okay, so the last thing for which we have derived the formula is the standard error of the slope. And that is the standard error of the regression equals. Okay, so I click into the cell with the 1.581, which is the standard error of the regression, divided by the square root of the sum of all the squared deviations from the mean, which is the 22, which is in my case cell G9, and then F4, and then that's okay. So for this we all have the formulas. So again, what I highlight now in, I don't know, a light orange, that is our data. And we need those calculations that I highlight now in maybe a light blue. And so then what we need is the mean. So we needed to calculate a couple of means and sums, actually only two means. And let's give that also another color, maybe a light green. And with that information, we just got 1, 2, 3, 4, 5 results that are commonly reported by a regression and which are very important. And I just put that into, I don't know, a light red or so, or a pink. So those are the results. And what we want to check next is if these results comply with what we get in Excel. So we don't need any more our formula sheet. We applied them. So I just delete them. And what I will do next is we want to run a regression on our data X, Y, and YI. So the way to do that is we go to Data, Data Analysis, and then if you go down, there is something called Regression. Say OK. And then Excel is pretty clear what it wants. Excel wants to have the input range Y, and my data has labels. So the label for YI is YI. Okay, and then we'll just click into the first row with the YI and drag everything down. Then we do the same for the input range, the XI, and now we have a bivariate regression. And then we can tell Excel where do we want to have the output range. We can put it into a new sheet or even a new workbook. But I want to have it somewhere close to where we can see our calculations. So I click it right next to our own calculations, and we don't have to worry now about everything else. And then we just say OK, and then we should see what Excel reports. Okay, so Excel reports a lot, and let's first fit to content. And let me just reduce the decimals here. And let's remove the decimals here also. Okay. And let's fit to content. Okay, first thing we see is we calculated a slope of 1. So now if we go down to the regression output, we see here the coefficients. And you see we have here an intercept of 3 and 1, which is exactly the same as what we got. But now we know how Excel actually calculates it. So now we know where the 3 and the 1 comes from. Then the standard error of the regression, that is in the regression statistics. So here we see the standard error of the regression, and we also know how to calculate that. And of course we have 6 observations, and there is still an ANOVA table. We'll keep that for later. But Next to the coefficients, we see the two standard errors. And those two standard errors for the intercept 1.200 and for the slope xi 0.337, which is exactly what we got. So now those are important results that are being presented to you when you run a regression. And now we know where they come from and how they are being calculated. So what we still have left is to think about what does this t-stat mean and the p-value, and also what is this ANOVA table all about. But we do that in the, we start working on the t-stat and p-value business with the next video. And let's just stop here and let me quickly show you what we still have in the slides. So in the slides I have a similar table. I didn't calculate everything what we just did in Excel. I only focused on the standard error of the regression, again the standard error of the intercept, the standard error of the slope, and we calculated those, and we see we get here indeed the same results. And on the final slide, before we go to the next topic, I showed you again the Excel output, similar to what we just did, what we saw here. Okay, so yeah, let's just stop here and then continue with finding out whether the regression coefficients are actually significant.